Okay, so problem 4.10a. Prove graphically or otherwise that the equation the tangent of x equals x has a solution, lambda sub n, between these two numbers, 2n minus 1 over times pi over 2 and 2n plus 1 times pi over 2 for every natural number. Okay, so I could try and draw this by myself, but this is going to be a disaster. So I'm going to just paste the function tangent of x here in black, right? So this is the tangent of x, and this is x, right? And so the equation tangent of x equals x means the points where these two curves coincide, right? These vertical black lines are the asymptotes of the tangent, right? So as you know, the tangent does something like this between the multiples or the odd multiples of pi over 2, right? So it starts at minus pi over 2, pi over 2. Here, this is pi over 2. Then this is 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. Okay. So the way to prove this graphically is to say that because the tangent is going to cover the whole, so the range of the tangent between minus pi over 2 and pi over 2 is actually infinity, right? The range of this function goes from minus infinity to infinity. So in this interval, the function y equals x is going to cut it at one point only, okay? Because this function is injective, so there's no way that these two functions can cross two times, right? And so this happens at every interval, right? So that's the way to prove this, right? Either graphically or in more rigorous terms, as I said, because of the range of the tangent inside this interval is going to be infinity. So the solution, there's going to be a solution here, right? And now the second part is to prove that the sum of these two, the sum of the square inverse of these solutions, lambda sub n. Okay, so this is lambda sub 1, lambda sub 2, lambda sub 3. Okay, you take these numbers, these values of x here, you divide by them and square them. The sum of this is convergent, apparently, right? So how do we do this? Well, we know that lambda sub n is greater than 2n minus 1 times pi over 2, right? This is the part of the definition of this. Now, if we square this, right, we have this and then this squared, and then this is 4n. Well, let's write it like this: 2n minus 1 squared divided by 4 times pi squared, right? So then if we do the cross multiplication, then we have 4 divided by 2n minus 1 squared pi squared, right, is smaller than lambda n squared for every natural number, okay? For every natural number, okay? But now this, so we have 2n minus 1 squared is asymptotically equivalent to 4n squared, right? So this term here is asymptotically equivalent to 1 over n squared pi squared. But we know that this sum from n equals 1 to infinity of 1 over pi squared 1 over n squared is convergent, right? This is convergent. But now the general term of this sum, okay, this sum, sorry, yeah, no, this is incorrect. This is 1 over lambda n squared, right? Now the general term of this series is greater than this series, which is asymptotically equivalent to this. So using the comparison test, we can say that this series will be convergent, right? Because this is going to be greater than the terms of this series, at least after the terms of this series, at least after some time, okay? And that's the end of